हेलो विस तो आज से हम लोग स्टार्ट कर रहे हैं क्लास 10th चैप्टर 3 ज्योग्राफी यू ऑल वाटर रिसोर्सेज. You already know that three-fourths of the Earth's surface is covered with water, but only a small proportion of it account for the fresh water that can be put to use. This fresh water is mainly obtained from the surface run of the groundwater that is continuously being renewed and recharged through the hydrological cycle. All water moves within the hydrological cycle, ensuring that the water is a renewable resource. You might wonder that if three-fourths of the world is covered with the water, and the water is the renewable resource, then how is it that countries and regions around the globe suffer from water scarcity? Why it is it predicted that by 2025 nearly 2 billion people will live in absolutely water scarcity and the need for the water conservation and management. Given the abundance and renewability of water, it is difficult to imagine that we may be suffer from the water scarcity. The moment we speak of water storage, we immediately associate it with the reason that role in or those that are drought prone. We instantaneously visualizing the desert of Rajasthan and women balancing many matkas, earthing pot used for the collecting and the storing water and traveling long distance to the get water. To the availability of resources varied of space and time, mainly due to the variation of in seasonal and annual precipitation, but water scarcity in most cases is caused by over exploitation, excessive use, and unequal access to the water among different social groups. Waste sorry water scarcity like to occur as you have read in a hydrological cycle. Fresh water can be obtained directly from the precipitation, surface runoff, and the groundwater. Is it possible that an area or region may have ample water resources but is still facing water scarcity? Many of our cities are such examples. Thus, water scarcity may be an outcome of large and growing population and consequent greater demand for the water and unequal access to it. A great population means more water, not only for domestic but also to produce more food. Hence, to facilitate higher food grains production, water resources are being overexploited to expand irrigation areas and dry season agriculture. You may have seen in many television advertisements that most farmers have their own wells and tube wells in their farms to irrigate to increase their produce. But you have ever wondered what this could result in? That in the may lead to falling groundwater level, adversely affecting water availability and food scarcity of the people. Post independence India witnessed intensive industrialization and urbanization, creating vast opportunity for us today. And large industries houses are as a commonplace as an industrial unit of many MNCs, multinational corporations. The ever increasing number of industries has made matter worse by exerting pressure on the matters on existing freshwater resources. Industries, apart from being heavy users of water, also require power to run them. Much of this energy come from hydrological powers. Today in India, hydrological power is contribute approximately 22% of the total electricity produced. Moreover, multiplying urban centers with large and dense population and urban lifestyle have not only added to the water and energy requirement but have further aggravated the problem. If you look into the housing society or colonies in the cities, you would find that most of these have their own groundwater pumping devices to meet their water need. Not surprisingly, we find that fragile water resources are being overexploited and have caused their depletion in several of these cities. Far we have focused on the quantitative aspect of water scarcity. Now let us consider another situation where water is sufficiently available to meet the need of the people, but the area is still suffering from water scarcity. This scarcity may is due to the bad quality of water. Lately, has been growing concern that even if there is ample water to meet the need of the people, much of it may be polluted by domestic and industrial wastes, chemical, pesticide, and fertilizers used in agriculture. Thus, make it hazardous for human use. You may already realize that the need of a hour is to conserve and manage our water resources to safeguard ourselves from health hazard, to ensure food security, continuation of our livelihood and productive activities, and also to prevent degradation of our natural ecosystem. Over exploitation and mismanagement of water resources will improve these resources and cause ecological crisis that may have profound impact on our lives. Multi-purpose river project and integrated water resources management. But how to we conserve and manage water? Archaeological and historical records show that from ancient times we have been constructed sophisticated hydraulic structure like dams, built of stone rumble reservoir or lakes embankment or and canal for irrigation. Not surprisingly, we have continued this tradition in modern time by building dams in the most our river basin. What are the dams and how do they use us in conserving and managing water? Dams water is traditionally built to impound water and rainwater that could be used later irrigate agriculture field. Today dams are built not just for irrigation but for the electricity generation, water supply for the domestic and industrial use, flood control, recreation, inland navigation and fish breeding. Hence the dams are referred to as a multi-purpose project where the many users of the impound water are integrated but one another. For example, in the Satluj Vyas River Basin, the Bakar Nagal project water is being used for the both hydel power production and irrigation. Similarly, the Hirakund project in the Mahanadi Basin integrated conservation of water and with the flood control. Multi-purpose project launched after the independence with the integrated water resources management approach, where the thought of as a vehicle that would lead to the nation to develop and progress, overcoming the handicap of the colonial past. Jawaharlal Nehru proudly proclaimed the dams as a temple of the modern India. The reason being that it would irrigate development of agriculture and the village economy with rapid industrialization and growth of urban economy. In recent years, multi-purpose project and the large dam have come under the great scarcity and opposition of variety for the reason regulation and damming of the water affect their natural flow, causing poor sedimentation flow and the excessive settlement of at the bottom of the reservoir, resulting a rockier stream bed and the poor habitat for the river aquatic life. Dams aquatic fauna to migrate, especially for the swamping the reservoir that are created on the floodplains also submerge the existing vegetation and soil, leading to the decomposition over period of time. Multi-purpose project and large dams have also been made cause of many new social movements like Narmada Bachao Andolan and Tehri Dam Andolan, etc. Resistance to these projects has primarily been due to the large-scale displacement of local communities. Local people often had to give up their lands, livelihood, and their much access and control over reservoirs for the greater goods of the nation. So, if local people are not benefited from such project, then who is benefited? Perhaps the landowners and large farmers, industrialists, and some few urban centers. Take the case of the landless in the village. Does it really gain from such a project? Irrigation has also changed the cropping pattern for many reasons, with the farmer shifting to water intensive and the commercial crops. This has a great ecological consequences like salination of the soil. At the same time, it has transformed the social landscape. Example, increase the social gap between the richer landowners and the land less poorer. As we can see, the dams did not create conflict between the people wanting different uses and benefits from the same water resources. In Gujarat, Sabarmati Basin, farmers were agitated and almost caused a riot over the higher priority given to the water supply in the urban areas, particularly during drought. Interstate water dispute are being also becoming common with the regard to share the cost and benefit of the multipurpose projects. Most of the objections to the project arose due to their failure to achieve purpose for the which they were built. Ironically, the dam that were constructed a control flood have triggered flood due to sedimentation in the reservoir. Moreover, the big dams have mostly been unsuccessful in controlling flood at the time to excessive rainfall. You may have been seen to or read how to release water from the dams or read how to release water from the dams during heavy rain. Aggravated the flood association in Maharashtra and Gujarat in 2006. The flood have not only devastated life and property but also caused extensive soil erosion. Sedimentation also means that the floodplains were stripped of the silt or natural fertilizer, further adding on to the problem of the land degradation. It was also observed that the multipurpose project induced earthquakes, caused waterborne diseases, and pest and pollution resulting from the excessive use of water. Rainwater harvesting. Many thoughts that given the disadvantage of rising resistance against the multi purpose project water harvesting system was visible alternative both socio-economically and environmentally in ancient India, along with the sophisticated hydrological structure. These existed in extraordinary tradition of water harvesting system. People had in-depth knowledge of rainwater regime and the soil types and developed wide-ranging techniques to harvest rainwater, groundwater, river water, and flood water in keeping with the logical ecological condition and their water need in hill and mountainous region. People built a diversion channel like the Gulls and the Kuls or the Western Himalayas for the agriculture. Rooftop rainwater harvesting was commonly practiced to store drinking water, particularly in Rajasthan. In flood plains of Bengal, people developed in inundation channel or to irrigate their field. In arid and the semi-arid region, agriculture field were converted into rain-fed storage structure that allowed to the water to stand and moisten the soil like Khaden and the Jaisalmer and the Johar in the other part of Rajasthan. In the semi-arid region, of Rajasthan, particularly in Bikaner, Palodi, and the Burmar, almost all the houses traditionally had underground tanks or tankas for the strong drinking water, storing drinking water. The tanks could be as large as a big room, or one household in Palodi has a tank that is 6.1 meter deep and 4.27 meter long and the 2.4 meter wide. The tankers were part of the well-developed rooftop rainwater harvesting system and were built inside the main house or the courtyard. They were connected to the sloping roof of the houses through the pipe. Rain falling on rooftop would travel down the pipes and was stored in these underground tankas. The first spell of rain was initially not collected as this would clean the roof and the pipes. The rainwater from the subsequent shower was then collected. The rainwater can be stored in the tankas till the next rainfall, make it extremely reliable source for drinking water. When all the other sources are dried up, particularly in the summer, rainwater are the palar pani, as the commonly referred to in these part, is considered the purest form of natural water. Many houses constructed underground rooms adjoining the tanka to beat the summer heat, as it would keep the room cool. Today, in western Rajasthan, sadly, the practice of the rooftop rainwater harvesting is on the decline as the plenty of water is available due to the perennial Rajasthan canal. Though the some houses still maintain the tanka since they do not like the taste of tap water. Fortunately, in many part of the rural and urban India, rooftop rainwater harvesting is being successfully adopted to store conserve water in Gadhor, a remote backward village in the Mysore, Karnataka village, have installed in their household rooftop rainwater harvesting system to meet their houses need. Nearly 200 household have installed the system, and the village has earned the rare distinction of being rich in rainwater. See figure 3.2 for a better understanding of the rooftop. Rainwater harvesting, which is adopted here, Gathor receive an annual precipitation of 1000 millimeter and the with 80% of collection effective and about 100 filling. Every house can collect use 550,000 liter of water annually from the 20 houses. The net amount of rainwater harvested annually amount to 1 lakh liters. And our chapter is now completed. I hope you do understand the chapter very much.